Hi folks, this is Tolbert. I'm creating this video solely so that you guys can get a head start on what's happening for the next week. So this is just the bare bones, just simply information that you should be sitting back right now listening to as I cover it. All right? So sit back and relax. Here we go. Some of the things that we're going to cover. We're going to cover Newton's first law, Newton's second law, and Newton's third law, the law of momentum. Newton's first law is also known as the law of inertia. Let's go. And my picture's just getting in the way over here. I'm just going to do that. Okay. 6.1, force changes motion. A force is a push or a pull or any action that is able to change motion. The young lady here looking at the golf ball, she's like, move! Unless she's telekinetic, that's not how it works. Newton's first law says that objects continue in motion to continue the motion they already have unless they're acted upon by a net force. If the net force is zero, the object at rest will stay at rest. If the object is acted upon by unbalanced forces, its motion will change. What does that mean? The law of inertia, here's what it is. I call it the law of laziness. Everything in the universe is lazy. It doesn't want to stop doing what they're already doing because it requires too much energy. When you're sitting on the couch at home being lazy, guess what? You don't want to get up and move, right? So you're sitting in one place, it requires too much energy for you to get up and move. Now, amazing enough, after you've got up and started moving, it requires the same amount of moving, the same amount of energy to stop moving. And who wants to add more energy since you're already moving? Nobody. So the law of inertia is laziness, is things want to do what they're already doing. The only way to change it up is that you have an unbalanced force, which means you have to have something bigger, better, or something like that to change it up. Newton's first law, often written in the terms of net force. An object at rest will always stay at rest, and an object in motion will continue in motion at constant velocity unless there is a net force. According to these vectors, in which direction is the net force? So look at these vector here. This is the biggest vector. This friction going this way. Is this arrow bigger than this one? No. So this one will only cancel out. So our end of the day, our net force will end up going that way. Both of these cancel each other out, so they're equal and opposite. This one is a little bit bigger than that one, so that's what you get at the end of the day. All right, forces that can be used to increase or decrease the speed of an object or to change the direction an object is moving. Inertia is a property of an object that resists changes in motion. Remember, if it's moving, it doesn't want to do it. It's lazy. It wants to keep on doing what it's already doing if it's moving. If it's sitting still, it wants to keep on sitting still. Now, in this particular one, objects with more mass have more inertia. Where's back to my pointer here. All right. Objects have more mass, have more inertia. So a bowling ball that is 5 kilograms has the tendency to want to keep on sitting still more than a golf ball. Conversely, if this is moving, it's going to be harder to stop the bowling ball than the golf ball. So which ball has more inertia? The one that has more mass. The bowling ball has more mass. All right, Newton's first law, there it is. An object at rest will stay at rest, and an object in motion will continue in motion at the same speed and direction unless acted on by an unbalanced force. This is just solving some problems here. So Newton's second law. Newton's second law tells us that motion cannot change without a net force. Newton's second law basically is where the math comes in. It's where the force equals the mass times acceleration. So it basically quantifies the amount of force is required to do something, to either change its inertia, change its speed, or change its acceleration. In this particular one, the Newton. The SI unit of force, as you already know, is the Newton, is defined by the second law. The Newton is the amount of force needed to accelerate a 1 kilogram object by 1 meter per second. Newton's second law. Here are some of the main ideas. There are three main ideas related to Newton's second law. Acceleration is the result of unbalanced force. Remember, if it's balanced, no change. It requires a change for something to accelerate. Got it? Anyway, a larger force makes a proportionally larger acceleration. Yeah, if you push something harder, it's going to go faster. Acceleration is inversely proportional to mass. So if you have something, if I have a certain amount of strength and I can push, I can only make it move as fast as I can make it move. If it gets heavier, I can't increase its acceleration. Let me put it more plainly. If you've got a shopping basket when you walk into the store, the shopping basket is empty, but you're able to move it or accelerate it pretty easy. You being a finite amount of force. As you add stuff to your shopping basket like you do at Costco, by the end of the shopping spree, that shopping basket is so massive that you are moving it, but you're moving much slower. As the mass went up, your ability to move it went down. Newton's second law. Unbalanced forces causes change in speed, direction, or both. Acceleration and force. The second law says the acceleration is proportional to force. If the force is increased or decreased, acceleration will increase or decrease by the same factor. Yeah. So if you push it twice as hard, it'll move twice as fast. And this is because in this particular instance, folks, the kilograms here is staying constant. Here I am pushing harder. The harder I push the same mass, it goes twice as fast. If I push half as hard, it moves half as fast. Acceleration and direction. Another important fact to the second law is the acceleration is always in the same direction of the net force. So whatever force is left, it's going to move in that direction. Acceleration and mass. The greater the mass, the smaller the acceleration for a given force. This means acceleration is inversely proportional to mass. That's the shopping cart scenario. As the cart gets heavier, you have a harder time moving it. The mass goes up, harder to move. The acceleration goes down. Here is the formula. Acceleration equals force divided by mass. The stronger the force on an object, the greater the acceleration. Its force is directly proportional to acceleration. If twice the force is applied, the acceleration is twice as great. Same one here. So the mass in the shopping basket is the same. In this particular example, if he pushes it twice as fast, it's going to move twice as fast. The other particular way is if you increase the mass, it becomes harder for you to move. The greater the mass, the smaller the acceleration for a given force. Mass is inversely related to force. An object with twice the mass will have half the acceleration if the same force is applied. So, keeping some important things in your mind. The net force causes acceleration. So that's whatever's left causes a change if it's imbalanced. If there's no acceleration, the net force must be zero. If there is acceleration, there has to be a net force. The force unit is newtons based on kilograms, meters, and seconds. So here are the different computations for how we solve for acceleration or force or mass. This is important. If you're looking for acceleration, you divide the force by the mass. If you're looking for the force, you multiply the mass and the acceleration. If you're looking for the mass, you divide the force by the acceleration. Newton's third law. Newton's third law, action-reaction, applies when a force is applied to any object such as a basketball. For every action, there is an equal and opposite reaction. Newton's third law, action-reaction. Newton's third law states that a reaction force creates a reaction force that is equal in strength and opposite in direction. There can never be a single force acting without its reaction. When sorting out action-reaction forces, it's helpful to use more of those diagrams where you have arrows pointing to the things. Woman sitting in a chair. You can kind of use arrows to show how forces are acting on her. When things are hitting, let's talk about Newton's third law, collisions. Newton's third law tells us anytime two objects hit each other, they exert the equal and opposite forces on each other. The effect of the force is not always the same. In this particular example, folks, notice this hockey player is 80 kilograms. This hockey player is 40 kilograms. Who's going to win? Would you rather be hit by one dude that's huge or one dude that's small? Yeah, you want to be hit by a guy that's small so he won't knock you out. Who's going to win here? The big guy, because he has more mass. The greater the mass, the greater the inertia. Momentum is the mass of an object times its velocity. The units for momentum is kilograms per meter per second. The law of conservation of momentum states that as long as the interacting objects are not influenced by outside forces like friction, the total momentum is conserved. So it means you don't create it or destroy it. You can always find it somewhere if you're counting. The result of the skateboarder throwing a 1 kilogram ball at the speed of negative 20 meters per second is that he and the skateboard with the total mass of 40 kilograms move backwards at the speed of positive 0.5 meters per second if you ignore friction. Kind of like jumping off a boat and it's in the middle of the water. You push off and you don't make it to the dock because the boat slides back underneath you. Collisions. When a large truck hits a smaller car, the forces are equal. The smaller car experiences a greater change in velocity, much more rapidly than the big truck. The big truck has more inertia. Greater the inertia, the harder it is to stop or start. And that is it, folks. That is it for this particular one. I hope you enjoyed it, and check out the videos that are linked in the folder.